Okay, so we have this example. Suppose that male students' heights are normally distributed with a mean of 65 inches and standard deviation of 44.2 inches. So what is the probability that a randomly selected male will have a height that is at least 63 inches? Okay, so the first thing that you want to do is try to graph this out. Let me use a different color. So let's graph this. So we know that the male's height is normally distributed. The mean is 65 inches and the standard deviation is 4.2. So we know that sigma here is 4.2. The mean is going to be 65 inches. Okay, so we want to know the probability that a randomly selected male will have a height that is at least 63 inches. So 63 is maybe around here. So here's 63. 63, and we want to find the probability that it's at least 63. So remember, at least means 63 or more, so we're looking for all of this area. So this one had nothing to do with central limit theorem. It was just a basic normal problem. So all we're going to use is norm CDF. Here our upper bound, not our upper bound, our lower bound is going to be 63 because that's where the area starts. My upper bound is going to be equal to infinity because it's going to go off to infinity. My mean, in this case, well, my mean is just going to be 65 inches. And my standard deviation sigma is just going to be 4.2. Okay, sorry, I don't know why it's doing that. Let me try to erase it. So sigma equals 4.2. Okay, so all I gotta do is just plug all of this into my calculator. So whatever calculator you may have, I'm just gonna go to distributions, normal CDF, lower bound. Well, my mean is gonna be 65. My sigma is going to be 4.2. My upper bound is gonna be my lower bound is gonna be 63, and my upper bound is gonna be 1 times 10 to the 99 power, or infinity. Okay, so what I ended up getting was 0.683. Okay, so there's a 68% chance that I will find a male whose mean or whose height is at least 63 inches. Okay. All right, so part B says, suppose we obtain 25 male students. So what is the sampling distribution of the sample mean? So here the word sampling distribution is a key word. So whenever we want to do the sampling distribution, remember that we want to, what am I doing over here? We want to go ahead and figure out whether 25 is large enough. Well, remember the requirements that if the original population is normal, since we already know it's normal, n doesn't really matter. So it doesn't matter what n is, okay? So suppose we obtain 25 male students. What is the sampling distribution of the sample mean? So we are looking for what is x bar normally distributed to. Well, we know that because it's normally distributed, n doesn't matter, so we can use the central limit theorem. We know that by the central limit theorem, the distribution is, the mean is mu and the standard error is sigma over square root of n. Okay, so here all we got to do is just plug in the numbers. Mean mu is just going to be the same thing. So the mean was just 65. So this is going to be 65. Sigma in this case, sigma was just 4.2. And now square root of n, and in this case is going to be equal to 25 since we're getting 25 students. Okay. So let me erase this a little bit. So 25. Okay, all we got to do is put this in the calculator. So it's just 65, and then I'm going to do 4.2 divided by the square root of 25, and what I'm going to get is 0.84. Okay, so there's my mean, which is still the same, and my new sigma is going to be this. Okay, so when do I know I have to use this? Well, I will tell you something like this. Use a sampling distribution to find the probability that the mean weight of the 25 students will be at least 63 inches. So this is very different than part A, because part A, you just randomly selected a random one male. In this case, you want to figure out the mean weight of those 25 people that you got. Okay, so the mean here is exactly the same. It's still equal to 65. And we still are looking for more than 63 inches. Okay, but the only difference here now is just going to be whatever my sigma is, because sigma is taking into account the 25 males that I'm getting. So we're still going to use normal CDF. So norm CDF. My upper bound is still going to be, my lower bound is still going to be 63. My upper bound is still going to be infinity. My mean is still going to be 65, but now my sigma is the only thing that's different. Now this is going to be 0.84. Okay, so I'm going to use normal CDF. My mean is still the same. My sigma changes, so it's going to be 0.84. My lower bound is 63 and my upper bound stays the same. So what I'm going to get is 0.9914. Okay, so the probability that the mean weight of those 25 students will be at least 63 inches is about 99%. So almost very likely. Okay. All right, so there's one problem where you had a normal distribution and you had a sample size. And the next example, we will do one when it's not normal anymore.